Problem 9.1 says use the symbol H0 for which hypothesis. So remember, H0 is the null hypothesis. The null hypothesis is the hypothesis that represents the status quo. Now, logically, that's how we should think about the null hypothesis. In terms of a practical sense of how we decide which is the null and which is the alternative, the null hypothesis is always the one that involves equals. So whether it's just a straight equals or an inequality with equals, so greater than or equal to, or it might be less than or equal to, the null hypothesis will always have that equals component. And that's what we're using the symbol H0 for. Problem 9.2, we're using the symbol H1 for which hypothesis? Well, H1 is the alternative hypothesis. Now remember, it can also be written as H with a little subscript A. So H1 or HA are both okay as the symbol for the alternative hypothesis. Now, the alternative hypothesis is, of course, the complement to the null hypothesis, and it's not going to involve equals, so it will either be not equals. If the null is equals, the alternative will be not equals. If the null hypothesis was, say, greater than or equal to, well, then the alternative hypothesis would be less than. If the null was less than or equal to, the alternative would be greater than. So the alternative is always the complement to the null. We know the symbol. In fact, there's two choices for the symbol for the alternative. And in terms of a logical perspective, we think of the alternative hypothesis as the hypothesis of change. So the null is the status quo, and the alternative is the change we're investigating. And quite often it's therefore the alternative hypothesis that the researcher is probably wanting to prove, but of course we have to use our sample to see what result we get. So problem 9.1 and 9.2 just designed to give you a little bit of a chance to think about the null and the alternative hypothesis. Problem 9.3, what symbol do you use for the level of significance or chance of committing a type 1 error? Now, the level of significance is represented by alpha. So alpha is the symbol. And of course, when we think of it as a level of significance, alpha is representing the size of the reject region or regions. If it's a one-tail test, we will just have one reject region and it will be of size alpha. If it's a two-tail test, well, then we have two rejection regions and each one is represented by alpha over 2. So we split alpha in two when we have a two-tail hypothesis test. Now, alpha is the level of significance, but it's also the chance of committing a type 1 error. Now remember, a type 1 error is the chance that you reject the null hypothesis when it really was true. And that's different to a type 2 error. A type 2 error is where you don't reject the null hypothesis and it really was false. So a type 1 error, well, that's what alpha is representing. And in a practical sense, alpha is the size of the reject region, or if it's two-tail, it's the combined size of the reject regions. So 9.3 is just to get you to think a little bit more about alpha. For problem 9.4, what symbol do you use for the chance of committing a type 2 error? So as we said, a type 2 error is where you don't reject the null and it really was false, and that's represented by the symbol beta. Okay, so problems 9.1 to 9.4, just a chance to do a little bit of revision on the basics of hypothesis testing.